Hey everybody, my name is Braden Ganetsky and I want to welcome you to my lightning talk. It is called Lambda, None of the Things. It's really nice that actually the conference organizers have given me a title card for this lightning talk. I almost called it a Lambda talk, which I guess it is. So before I get started, there's just a little bit about myself. Famously, I hate lambdas. Lambdas are a really interesting feature in C++. They were introduced in C++ 11, and unfortunately the world has been worse off ever since. This talk is effectively a manifesto, a call to action, and you'll see as the talk goes on. So here's how it's going to go. We'll talk about closure type names, we'll talk about teachability, code readability, translation units, and boundaries. So, closure type names. Does anyone know what the name of a lambda type is?
Disgusting.
Yeah, there's no name for a lambda type. So let's say I have this lambda here, which is a perfectly reasonable lambda to write, apparently, according to some. And then I will call it like this, which is obviously an invalid way to call this lambda, right? And then this is the error that I get. Okay, yeah. That's a reasonable name for my type, right? Yeah, okay, so any reasonable person will say, yes, this is what my types should be called. What if, I included some code from, someone gave a talk about lambdas yesterday, what if I included some code from that, and then I tried to call this code, referencing the code that I included. This is the error that you're going to get, which now the name of my lambda is displayed as a file path, which if I know anything about C++, it's that, names of types are identifiers, names, not file paths. Okay, so that's closure type names. Let's talk about the teachability of lambdas. So let's say someone somewhere wrote a blog post and they wanted to teach someone how to write stood apply in an interesting way that was useful. So they might write this. And the thing is, they would argue that, yeah, this is stood apply. And yeah, it works because you have the no except of a lambda. And this is, of course, a perfectly reasonable lambda for someone to write. And then you have decal type of a lambda that is, again, perfectly reasonable to write. And then this is the body of the function, which, again, is that same lambda that is perfectly reasonable to write. If you can count the number of stood forwards in this lambda, I will give you a prize. Yeah, so obviously I'm being sarcastic, and this is completely ridiculous. This is unteachable. How would you explain this to someone? And I disapprove of this blog post, whoever wrote it. Because realistically, what are you doing? And then also, even with a simpler example, this is how you do lambda captures, and this is a reasonable way of doing lambda captures in C++. Now imagine a student comes to you and says, hey, why is there an ampersand not associated with an identifier? And you would go, oh, yeah, well, that's just lambdas. Why is there a leading ellipsis? And you go, well, yeah, that's just lambdas. I mean, unteachable and unreadable, as you've seen a few of the things I've shown so far. Let me show you some more readable code. Again, someone gave a lambda talk yesterday, and this is from the code. Who's looking at this and going, yeah, that's a unique pointer? No, it's not, right? So, okay, well, here's an overload set. And it's yeah, maybe if you squint your eyes and leave, then this is an overload set. And then maybe, yeah, okay, I'll capture some things in this. But lambdas inside lambdas. And when we're talking about lambdas inside lambdas, there is someone else who is actually not me who sent me this code, someone who is not named on this slide. And here you'll have a tuple cat helper that has a lambda, which has a lambda, which has a lambda, which has a lambda. And of course, yeah, this is readable, right? No, it's not. Who's reading this stuff? And then finally, I'll talk about translation units and boundaries. Look, let's say I wanted to extern const auto lambda. I wanted to declare a lambda and then define it later. You're not allowed to do that in C++. And so let's say I wanted to get around that and then have a static const expr auto, here's a lambda, and then I want to define one of the functions inside a source file and then use that inside of another source file. Now, the interesting thing is, it's approximately this conversation that I've been having with a few people for the past few days who are maybe, supposedly C++ experts, and I don't think we've come to a conclusion. So how do we pass a lambda across a boundary? Well, we could use a function pointer, but they can't be used for capturing lambdas. We could use std function, but that's type erasure internal virtual call. That's bad. Horrible ergonomics. So in conclusion, stop doing lambdas. They have played us for absolute fools. Thank you so much.